My name's Perry.
Today we're going to talk about forces, the normal force, tension, all that. So sit back, relax, and here we go.
Alright.
I'm finna get this boy.
I gotta close the window before I record, cause New York don't know how to be quiet.
What's good, man?
Stand up.
I want to fight. I don't know what you talking about. Let's go. Right now.
Hey man, I want to fight you, but I'd rather talk to 3 new laws.
Man, what you talking about, man?
First law, inertia. An object in motion stays in motion unless acted upon an outside force.
Well, since you over here talking about inertia and all this other good stuff, continue, because I ain't got time for nothing else. I was trying to fight you, man. God, no. Well, I think I might have a deal about the second law. Force equals mass times acceleration. My mass times the acceleration that I was trying to push you with, but you want to go talk about the first, second. You know the third law, huh?
Of course I know about the third law. It's an action. For every action there's an equal opposite reaction.
Bro, hold on, pause. Take me spot. Okay. Why are we trying to push this? You know that you just told me that law, talking about for every action there's a reaction. So, I mean, if we push on this, it's pushing right back at us. So we really can't push this, huh? I guess I can't do that push to start. I wanted it though.
Now we're continuing with forces. We go into F net, which is the total of forces that are being used.
So the force net is basically mass times gravity. Then you got the normal force. You might have tension sometimes, but I mean, we ain't pulling. I really push you, but you ain't want to fight. I try to tell you to fight. Dog it. I'm trying to say normal force, mass times gravity, and if you calculate all that, it equals to mass times acceleration.
So what you're saying is, if we didn't have normal force, we'd fall into the center of the Earth. But if we didn't have mass times g, which is mass times gravity, we're flowing above the clouds in space. I don't mean smoking, man.
Well, your force net that you just talked about, right? I just hit you with about, I don't know, my mass about 160, acceleration about 2, maybe 3 miles per hour. It don't matter. Anyways, you can all calculate this by saying the force net minus my mass times gravity equals MA. You can solve for MG or you can solve for FN.
But what about friction? Does that have an effect?
Well, that has a major effect because friction is the only reason I stopped beating you up, really. That's the only reason. But the friction, it acts against you in the negative direction. So if I was walking this way, friction walking that way to slow me down. That's the only reason I didn't whoop.
Okay, there's 2 types of frictions.
Isn't there mu K and mu S? Mu S, which is line, swoosh, and an M. It's like M, it don't matter. Mu S is static, which is standing when you're standing still. Mu K is kinetic, when you're moving. Oh, moving. Hey man, I thought I was supposed to be teaching you. You over here teaching me. I'm teaching you. We both teaching each other. It don't even matter. But since I'm already teaching right now, we gonna talk about tension. You know, that not tension in a relationship, like tension in a rope. You know, because both ways go. All right. As you can see in this thing we have set up right now, you can see the tension is same for both of them, because if I pull this way, the tension is the same if I were to pull this way. And if I pull this way, The acceleration is positive going this way and negative going up this way. Okay.
Ladies and gentlemen.
Okay.
Welcome
now
to the
we
main
are done
event.
talking about forces.